What's given in the problem? There is a disk and it is rotated with constant angular velocity omega about this axis, and the radius of the disk is r, and the magnetic field in which the disk is kept is b, and the surface charge density of the disk is sigma. I'm going to take a little longer time in this video to explain this. So how to move from what we know to what we don't know. See, this is unusual. This problem is unusual. So how do we do this? First thing what we know is, suppose if there is a current carrying loop in a magnetic field B, its area is A, then we know that torque acting on this loop is BIA, especially when there is only one. If there are n turns, it is NBIA. So we know only for a current carrying loop. But in question number 10, first time we have been exposed to a charge moving around. Suppose if the loop has a charge Q. When this loop is rotated, current is generated. How? The charge is rotating. So that time we discussed that the current is frequency into charge. Hence, if a loop is there with charge Q, then the current will be frequency times charge, that we discussed. So here is a case. This particular thing has been expanded to this. How? We have a disk, and the disk has a uniform charge density sigma. Uniform charge density sigma. How do we deal with this? What we know is, for a current carrying loop, it is BIA. Even if a charge is moving around, the current can be nu into Q, and in such case, we can write that torque is equal to B. In place of I, we can write as frequency into charge into area. So current carrying loop, this is the torque. If a loop has a charge Q rotated with angular velocity or rotating with frequency nu, then it will be. Then if it is rotated with angular velocity omega, then we know that omega equal to 2 pi nu. Then nu can be written as omega by 2 pi. In such case, torque will be equal to omega by 2 pi into Q into A. This is what we know. But we have a disk right now. But how do we imagine a disk? A disk can be imagined to be having very many number of small loops. So what we are going to do is, we are going to take one such loop here. If you take a loop and if you just cut the loop and spread it, and it will be like a line. When you cut a loop, this loop has a small thickness, let us say dx, and this loop is having a radius x. Then this length will be equal to 2 pi x. So 2 pi x, because radius is x, means this length will be 2 pi x, and the thickness is dx. Then the area of the loop, because we are going to consider this disk as to be composed of very many number of small loops. So each loop has a varying radii. So we are taking one such representative loop. That loop, let's say x, that loop has a radius x, then its length will be 2 pi x, and it has a small thickness, then that is dx. Then the area of this loop will be 2 pi x into dx. What they have mentioned here is, charge on 1 meter square area is sigma. That is what the meaning of surface charge density. So this area is 2 pi x into dx. So if the disk is split into very many number of small loops, and each loop, any one such loop, has an area 2 pi x dx. When you consider the first loop, x is equal to 0. When you consider the last loop, the total radius of the disk is r. The last loop has a radius r. So 2 pi r into dr in such case. So the area of a representative loop is 2 pi x into dx. Then the charge is equal to surface charge density into area. Since it is one small loop that is composed, very many number of loops is making up this. So the charge, whatever the charge that loop contains, is a small charge dq, equal to charge density into area. Charge density is 2 pi x into dx into sigma. Charge density into area gives the charge. When this is rotating, as we discussed here, current is equal to frequency into charge. So charge on a loop is 2 pi x dx into sigma. Then when the disk is rotated, the current generated in the loop, It's a small current generated in the loop will be frequency into charge. Charge is equal to 2 pi x dx into sigma, and frequency is equal to omega by 2 pi. So it is omega by 2 pi into 2 pi x dx into sigma. So 2 pi and 2 pi will be cancelled. Then this is equal to omega sigma x into dx. This is the current. We know that this one loop experiences a small torque d tau. D tau is equal to, we know that torque is equal to BIA. We have just found out I is equal to omega sigma x into dx and B into area of this. So the area is pi x square. Hence, this B, I is B omega sigma x into dx. So BIA, A equal to pi x square. Then the total torque will be summation of all the torques. This summation of all the torque can be written as integral d tau. From where to where? When you start imagining, the first loop has 0 radius, the last loop has r radius. Hence, integral that runs from 0 to r d tau. So the total torque tau is equal to integral d tau, that is b omega sigma x dx into pi x square. So b omega sigma pi can be taken out. So b omega sigma pi, all are constants taken out. Integral x square into x is x cube into dx 0 to r. Hence B, the total torque experienced by the disc is B omega sigma pi into r power 4 by 4 minus 0 by 4. So the net torque experienced by a disk of surface charge density sigma is B omega sigma pi r power 4 by 4.